Good morning, everyone. My name is David Zapka, and this morning we are going to be covering the SDS2 2015 connections, how those are different in 2015, what's new with those, and whatnot. If you do have any questions throughout the webinar, please go ahead and use the questions pane in the GoToWebinar toolbar there. And I'll try and get to those at the end of our webinar when I'm all done with everything. I'll answer those questions for you then. So first thing I want to start off with here is I just want to cover some of the new options or enhancements that have been added to 2015 to help us out with our connections. So we've added the two different design methods. So one design method we've added is the Eurocode, and then we've also added the CSA 10th edition in there as well. One thing that people have been asking for and requesting quite a bit for a while now is for SDS2 to be able to design a through shear plate with axial loads applied. So in SDS2 2015, you'll be able to do that now. Just a quick example of that, if I go into my model here where I have a tube column, I'll go ahead and edit this beam, and I'm going to change this over to a shear connection, and I'm going to go ahead and specify a through shear plate. And then in my loads, I'll go ahead and add in here a tension and compression of 20 kips. I'm going to go ahead and copy that whole right end. And then I'm going to go ahead and edit this beam on the opposite side. I'll go ahead and paste that information over here. So now I have my shear plate connection there. If I look at the loads, we have 20 tension and 20 compression. Okay, in the past, SDS2 would not give you a through shear plate connection here, and it would tell you that axial load was not applicable in this case. So now here in 2015, we see we will be able to get that connection designed there for us. Okay, now I do also want to point out that the version of 2015 that is currently available does not have all these options that I'm showing you. However, in another release of 2015, you will get more of these options. So I'm kind of showing you some things that are in the works or have been done for the next release already. So something else that's new is field welds can be displayed in modeling. And then along with that, also kind of related a little bit, we also have backup bars for welded moments are going to be available or be seen. So just to kind of show you that in the model, if we go ahead and take a look over here, I just have a welded moment. And we can see we have the backup bar and we have a field weld displayed. Now the welds, if I go into display options, I can turn those off just by unchecking welds. And then it turns those off just along with the shop welds currently. The backing bars, you don't necessarily have to display those in modeling. Under our options pull down, if we go into job options and moment plate design criteria, you're going to see a new tab in here, backup bars on welded connections. You have options for the material type, the grade, whether or not you want to actually create those solids in the model. You have bill of material options to determine how those are going to be shown in the bill of material, or we don't even have to show those in the BOM if we don't want. And then at the bottom you have a schedule based on the connection width, the minimum connection width and max connection width, the size of the backup bar that you want generated for that. Okay, other options that we're going to have in the member edit window, we are going to be able to adjust the field weld size or the length as well for HSS pipe or vertical brace, and I'll kind of demonstrate that a little bit later. In member detailing fabrication options, we now have options for the total notch width clearance on tube braces, and we can also set the hole type for our HSS erection bolts in the gusset plate. So just to show you that, I said they were in member detailing fabrication options. If we go to the vertical braces tab, we see we have the hole type now, and then we have the total notch width clearance that we can specify. So the notch width clearance is going to be split equally on both sides of our gusset plate for us. Okay, again, back in the member detailing fabrication options, but for beams this time, we have an option to provide minimum cope depth, and what this is going to do is when SDS2 designs the connections, if this option is turned on, it ignores the K distance when determining how deep the cope needs to be cut. So this would provide us with a smaller cope depth than with this turned off, because with this turned off, it does take the K distance into account to clear it. There's also an option for the minimum clearance for cope, which specifies the distance that we see here in the picture. And again, flipping back here, that's under fabricator options, member detailing fabrication options. Under the beams tab, we just have a checkbox for provide minimum cope depth, and then we have the minimum clearance for cope that we can set there. The final option here is an option to extend stability plates to the column web, another pretty long-standing request. So in previous versions of SDS2, if you had a shear plate extended past the flange of a column, you could get a stability plate that didn't extend all the way to the column web, and then in some cases you would have actually got that. And to display this, or to show you this, if we take a look, I have this situation set up already. So right now, if I snap to this surface, we'll go ahead and we can see. Let me turn some display options off here. Maybe clean it up a little bit. So in there, we can see that that stability plate is not extending all the way to the column web. A lot of times this is a requirement that people ask for. So in the member edit window now, under connection specifications, this is the right end of my beam, we have an option to extend the stabilizer plate to the web. And when I do that and process, that's going to force SDS2 to always extend that to our column web. You could do that. You could set that up in your auto standard connection setup too if you needed it in there as well. Just showing that to you right there for now inside the member edit window. Okay, so now before we go on anywhere else, what I want to do is point out a few things that are going to be different for us concerning connections and editing connections, as far as differences in the member edit window and some other ways now that we'll be able to edit connections to help us out. So if I come up here and edit my member, most of you have probably seen the new redesigned member edit window, so you're getting familiar with the look of this. I'm just going to point out some things that are different as far as connections are concerned. So the first thing to point out is up here by our connection, we have now just a force and a graphical checkbox. You don't see the user or the system radio buttons anymore. Those are gone. The other one that you're going to see, you used to have a lock checkbox here. Well, there still is a lock feature. That has just moved, and that has moved up here to the left end settings ribbon, and that's the lock or unlock right here. So you see when I click that, now everything down here has become a read-only field because the entire left end is locked. Same with the right end settings. Your lock has moved up here on the right end settings ribbon. Okay. You can view the limit states right in here in the member edit window, or if I have one of these ends turned off, that limit state for the left end is going to move underneath my tree there. The other difference you're going to see is you're going to see changes made in the member edit update those limit states automatically. So there's no longer a redesign connection button on the bottom. Anytime you make a change to this window, it's basically like it hits redesign connection, so it redesigns it on the fly as you make changes. And if I go ahead, I'm just going to turn that right end settings off. Now if I make a change to my left end settings over here, watch the limit states table. So for example, let's say I come in here and I change my shear load. Watch my limit states table. That's going to, as soon as I change and hit tab, notice it updated because it redesigned that connection right there. What you have to be careful for there and watch out for there is by doing this, there's a portion of connection design that is left out, and that's the framing situation part of this. So basically what this means is when it designs on the fly, it's only designing the connection for the member that it's framing to, and it's not looking at clearance issues that other members framing nearby might present. So something just to be aware of with that. You can also now save user-defined connections directly from the member edit window. So the way we would do that after we made all our changes and we want to save this user-defined connection, up here on the end ribbon again, either the left end settings or the right end settings, next to the lock, there is a button here to save as a user-defined connection. So we can do that directly from the member edit window, and we'll walk through that doing one of those here after a bit, just pointing out some of the differences that we see now. Okay, so another difference in 2015, I'm going to cancel out of the member edit window, is that connections are now what we consider a connection component. Some of you probably attended and have seen custom components in the past. We had a webinar on custom components. Connection components are very similar to those with some differences. So basically any system design connection now is going to be a component, and you notice when I hover over that, it goes ahead and it highlights the entire component, and when I double click on that, it brings up this connection component, has the fields in here for my connection component that I can modify. So I could make changes to my connection now without actually going into the member edit window. Maybe if I know I'm just specifically looking for needing to change specific fields of this connection, I don't have to deal with the clutter of everything else in the member edit window, and I can use this here. Okay. You have the same lock, unlock that you have in the member edit window right up here at the top. You can also save a user-defined connection directly from this member edit window with the button up here at the top. Other things you can do or to be aware of in here, if I edit this component and then I realize I need to actually be in the member edit window, down at the bottom you have a edit member button. That's going to close that window, bring up the member edit window. Now be careful with that, because if I were to make a change in this connection component window, let's go ahead and just say, let's say we forced that connection. So I just checked that force box. Any change I make in here, if I don't click OK, it's going to throw that out. So if I hit edit member now, force will not be carried over to the member edit window. Notice it's not checked there. However, if I were to force this connection, click OK. Okay, it's going to mark that for processing. But now when I edit that member, notice that setting carried over. So just something to be aware of and watch out for there. I'm going to uncheck that. And I want to go ahead and process that to get all my connection and my solids back. So connection components, another thing to point out with those is your selection filters. With the default selection filter, when you do that, it's going to highlight and select your component. If you have this set to all, it's going to grab the component. And if you choose the connection components filter, that is also going to have and select the connection components. There is a new filter in here called Legacy Default, and Legacy Default is actually going to act like 7.3 and previous versions, where if I highlight or hold my mouse over there, it's just going to grab the material. So now when I double click, it'll edit the material. You can also edit your individual materials with your default filter. If you right click, then you have your select other or your edit other in here, where you can choose the material or the bolts or the welds or anything like that as well. So different ways of going about that and selecting those different items. So now let's get into actually making some modifications to these connections and seeing how this works. So before we do that, I want everybody to understand how previous versions, so version 7.3 and previous worked, and then I want you to understand how 2015 works differently than those. So I'm going to go back to my PowerPoint slide here, and right now this is how user connections worked in version 7.3 and prior. So the way that worked was, first SDS2 had to go through and design a connection. Okay. Then you would go in, you would set the user radio button, which would lock all the connection variables. Then you would make adjustments to just the ones that you needed to change, and SDS2 at that point might kind of help you out and make some geometric changes, but there was no design. So basically what it would do is maybe increase like the angle length if you change the number of rows of bolts, but nothing real major. Okay. Once that was done, you would get a user connection note in your design calcs indicating that it's a user connection, and at that point also the connection would no longer actually go through Process and Create Solid, so it wouldn't be redesigned based on framing situation changes or anything like that. So once it was user, we were kind of in complete control of that in version 7.3 and prior, and SDS2 really didn't help us out much. So in 2015, we no longer have the same types of user connections that we had in the past. So you might refer to these now in 2015 as a user modified connection, or maybe a you'll see in the member edit window later, you'll see a flag that says connection design locked, it'll say connection design lock set. Okay, so the way that this works now is SDS2 is going to design a connection. The user is going to go in and lock the individual variables that they want to change. So that's different from previous versions, because in previous versions you had to lock every field. Now we're able to lock just individual variables, and then SDS2 is going to redesign the connection around the locked variables that you locked. You won't see a user connection note in the design calcs. You will see a note that tells you the number of locked variables that are indicated, and we'll look at this, where that's at. Okay. Then later on, if a framing situation changes or whatever, the connection is going to be redesigned again around your locked variables when the member goes through process and create solids. So let's take a look at just a fairly basic, simple example of this. And what I'm going to use is just snap into that surface, and then I'm going to go ahead and use this clip angle connection as an example. So I could go to the member edit window and I could make changes through the member edit window, or I'm just focused specifically on this connection. So I'm going to edit the connection component. And what I'm going to do in here, I don't have to set user like I did in previous versions. Remember, that is gone. But what I am going to do is I'm going to come down here to my near side clip. So I have my near side clip. I get the images over here on the right to indicate to me which variables I'm changing. If I don't like that, it's cluttered or whatever, I can get rid of that by unchecking show images, and then that goes away. So I'm going to turn that back on. And what I'm going to do is I'm going to come over here to the C variable, which is the number of rows. Now to change this, right now it's read only. I have to lock that. And now that variable is locked, and it will design this connection right now with 2 rows of bolts. Or if I want that to be designed with, say, 3 in this case, I'll go ahead and do that. When I hit Tab, you may have noticed the limit states table over here updated because, again, just like I explained in the member edit window, this is redesigning on the fly. Okay, I'll go ahead and say OK. I don't want to change all. I'm going to adjust my depth check here so that we don't get confused with the beam in the back. I'll process and create solids. And now I get that redesigned with 3 rows of bolts. Let's take a look at the design calcs. So I'll go ahead and edit this. And first thing to point out in the member edit window, notice I now have a flag that just tells me there are connection design locks set. So that means I locked one of those variables. I'll look at the design calc. And this is on the left end. So what we're going to actually see at the bottom of the second page in this case, we're going to see connection design lock summary. Just tells us that we have 1 variable locked. And then on the page with the limit states, in the past you would have seen a big user connection note above the limit states. Now we don't get that. Okay, this connection is designed with that 3 rows that we had locked. Now, one of the other benefits to this is that when a framing situation or something like that changes, this connection can be redesigned with my locked variables. So one example of that is I'm just going to go ahead and move this member now, and I'm just going to move it up 1.5 inches in the Z direction. Okay, confirm that. Process and create solids. Now that's going to require probably a deeper end prep, a deeper cope on that, and we could see it did go ahead and design that for us, moved that clip angle down if it needed. It makes it a lot easier when we get changes. Now, just to show you kind of the difference and understand and see where this differs from 7.3, I'm going to get into a 7.3 model that has this exact same situation. So now I'm in 7.3 to show you some of the differences. I'm going to snap to this surface. And in 7.3, I'll go ahead and edit my beam. I'll go to my near side clip. I'm going to have to change this to user, and then I'm going to have to scroll down here. And first off, the bolt rows in the web, I'm going to change to 3. And if I wanted the bolt rows in the outstanding leg to match, I'll go ahead and change those to 3. I'll go into my far side clip and make certain that that is all updated or the same. So changing all that to 3. Okay, no, I don't want to change all. And okay, so it kind of screwed that up there a little bit through my clip angle all the way up top. Let me adjust that correctly here. For some reason, the top of my near side angle got screwed up, so I believe that should have been 1 3/4. Okay, so things are getting thrown off already, but let's go ahead and say then that we move this member up the 1.5 inches like we did in 2015. And what's going to happen now is, since this connection can't go through process and create solids anymore, my end preps don't get updated. It can't adjust that connection really any way that it needs to, and we have a lot of fouling going on there. So you see how in 7.3 you lock everything in and then it can't be redesigned, whereas in 2015 we locked the one individual variable, and then when we made changes, then it got updated for us. So some of the differences that we see there. Let's just take a look at a couple different situations and where this might help us out. So one of the big areas that I talk to people a lot about and we run into a lot of problems and people struggle with is brace connections. Okay, so looking at a brace connection, remember I'm in 2015 now, and let's go ahead and say maybe on this particular connection here, I want to increase the rows of bolts for this clip angle. So fair enough, I'm going to go ahead and edit the connection component. I'm going to go to my clip angle, and again, I'm just going to do a simple change here. I'm going to increase the rows to 5. Now, I'll process and create solids, and notice what that did was increase the rows. It was able to also increase the width of that plate, and then it also readjusted the clip depth and clip length options over here to keep this gusset plate cut 90 degrees to the brace. In 7.3, let me hop over into 7.3 and kind of show you what that might have looked like when we did that. So in 7.3, I would have edited this brace. I would have gone to the vertical brace clip. I would have set to user. Rows of bolts I would have increased to 5. It would adjust the angle length for me. However, it didn't increase the plate width for me. So I would have to go in here. I would have to come into my VBR12 and I would have to adjust that plate width. Let's go ahead and increase that. I added 2 rows, so let's go ahead and say that was 1-7 and 7/8 now. Okay, so that increased my width, but then I'm left with the problem now to where my clip length, clip depth, all that isn't updated. I would have to go in there and readjust all that, whereas in 2015, I locked the one variable. It was able to figure out and redesign everything around that. Even if I were to come in here and make another change, so let's say I lock another variable in here, and in this particular case, I want to increase the length of my plate. So my gusset to beam and column, I can increase the B dimension here, which is my length. So let's say that needs to be 2 feet 8. Say OK. Process that. So now it's redesigning. I locked 2 variables, and it's redesigning around both variables that I had set. But again, the clip options here to get that correct was all figured for me a little bit. So we can kind of start to see how some of these things work and what it's doing for us here. Now, one thing to watch out for, since we're on the topic of gusset plates, if you have a shared connection, okay, let's say we have a shared connection up here, these are still components and you can edit the component, but just be careful when you're doing shared connections, because when you edit that connection component, it's not always really obvious if you're going to be making changes for the connection on the left-hand side of my window or for the right-hand side of my window. So double click on that. One way to be sure of which connection you're changing there is up at the top in your connection component, it's going to tell you which end of the member. So in this case, the left end, or in the tree over here, you have left end indicated. So I know that in this case, I'd be editing the left end connection for the brace on the right-hand side of my window. On the safe side, sometimes you may just go ahead and edit the member in this case, and then you can be sure that you're changing the right side. So, okay. Again, different things to show you here. Maybe I edit this gusset plate component down here at the bottom, and I'm just going to make changes. Maybe I only want 2 rows of bolts in my claw angles here. So I can go ahead and do that. I'll come down here to my rows and make that 2. Okay, so again, just to kind of show you that it's redesigning the whole connection around this, I just locked in 2 rows of bolts to be in my claw angles. And now you notice that the angles got larger, the bolts got larger. I believe we now have 1-inch bolts instead of 3/4 like we did before. Lessening the number of them, it required larger bolts to be used. So it's going to redesign around that. I talked about earlier being able to edit the field weld size and length. Let me go back into display options and turn my welds on. Remember, we'll be able to just see our field welds, display field welds. That's my blue weld here. And I can actually increase the length of that or the size of that. So if I edit that connection component and I come in here, brace connection to gusset HSS welded, we now have a field weld size and length. So if I need to increase that to, say, 10 inches, okay, it's going to design that connection again with the locked variable of 10 inches for my field weld length. Okay, so again, it was designing around that. Just one other example here real quick, and then we'll look at some different things we can do with user-defined connections to help out. I'm going to move over to my welded moment connection. I'm going to go ahead and edit this, and I'm going to change this to a end plate, and we'll do a bolted moment. And right now we're going to get a bolted moment with 8-bolt pattern on both the top and bottom flanges. Okay. In some cases, I see and I get the request for 8 bolts in the top flange, 4 in the bottom. Well, it's not something that SDS2 automatically does. However, I can come in here and edit this connection component now. And remember, I can do all these changes through the member edit window also. When I'm working specifically with connections, I find it easier in 2015 to just go into the connection component window. So that's why I've been doing that here. Now, I could come in here and go to my bolts. And I have the bolts above bottom flange, bolts below top flange. I only want 4 in there. Right now I'm getting 8. So I'm going to go ahead and lock in the rows, change that to 1. Same thing for the bolts below the bottom flange. I'm going to change that to 1. And if you paid attention and we're looking at some of these other fields, you would have seen some of these other fields updating. One of the fields that updated was my rows of interior bolts up here. So by taking away those, it added some interior bolts. I'm going to go ahead and change this, lock those variables in, and 0 those out. That way it gets redesigned with just the 8 bolts on the top flange and the 4 bolts on the bottom flange. Process and create solids to get that. Okay. One other problem I see there then, my stiffener runs down. Now, I could go in there, adjust my stiffener dimensions, or in this particular case, I'm going to come in here to my moment stiffeners, go to my bottom stiffener, and I'm just going to go ahead and get rid of that, so we don't need that stiffener. And there we have 8 bolts in top, 4 in bottom. Again, if we didn't need that stiffener up top, we could get rid of that there as well. So just some different examples. Get your guys' minds running on the possibilities with some of this stuff. So, okay, that's user connections and the difference in 7.2, 7.3 and previous versions to now in 2015, how that's working. I'm going to go into user-defined connections now a little bit with user-defined connections and how we can save those and some of the things that we can do with those. So before I actually do that, again, I'm going to go back to my PowerPoint here and show you kind of the difference and explain the difference in the way that version 7.3 and previous worked, and then I'll show you how 2015 worked. So in 7.3 and prior, with a user-defined connection, all the connection specifications from the user-defined connection were copied to the member. SDS2 would design a connection without looking at the user fields, so it designed a system connection, and then all the user fields were copied over to the member and would replace the system values. Again, SDS2 might make some geometric changes, but no design, and you would get a user connection note in the design calcs. In 2015, all the connection specifications from the user-defined connection are going to be copied to the member. All the locked variables are transferred to the member, and then SDS2 designs a connection around the locked variables. And then you get no user connection note in the design calcs. You'll just see the number of locked variables indicated for you. Okay, so let's take a look at that. And what I'm going to do is I'm just going to go ahead and use a simple shear plate connection here. And there's a reason for it that we'll get to in a couple minutes also. Okay, so on this user-defined connection, I'm going to edit the shear plate. And I'm going to come in here and I want to lock in a few different variables with this. I'm going to lock in my plate thickness, so I always want this plate to be 3/8. And I'm going to come in here, I'm going to say I always want 3/4 bolt diameter, always want hole type to be short slot. I'll leave the rows, my vertical, the first hole I'll leave. I do want to change the vertical edge distance to say 1.5. Horizontal to first hole I always want to be 1.5, and then my horizontal edge distance I want always to be 1.5 also. So I locked in several variables there. Going to hit OK. Now I didn't save the user-defined connection yet. I just want to go ahead and show you something here. So now what I want to point out to you is it redesigned that connection around the variables that I set. If I come in here and select Other, notice my material is getting an S3 piece mark. Well, the reason for that is because before the webinar, I went into my standard fabricator connections under the shear plate standard piece marks, and I set up a bunch of standard plate piece marks in here. Now, in previous versions, it was kind of difficult to get SDS2 to use these piece marks because there was no specific way to tell it to design a shear plate connection from something out of this table. Now, if I set this table up and I do my connections locking in the variables, it forces it to match this table, and then I get my shear plate standard piece marks. If I want to go ahead and save this as a user-defined connection, I can do it right here from the component edit window, and I have the save user-defined connection up here at the top. So it's going to bring up my user-defined connections. This again looks a little different than previous versions. I can go ahead and select New here, and we'll just call this a standard shear plate. Okay. Click OK there. Now, if I wanted to go ahead and apply this to another situation, I can even do it to a different framing situation because it should redesign that and update. I can go ahead and edit that beam, set user defined, pick the user defined connection I want designed, process that, and now it should redesign with that same connection, but if I go over here and show you the material piece marks, I got the S3 to match again. So I have that user-defined connection in there. You can also save user-defined connections or modify them by going same way you did in the past by going to your job options and going to user-defined connections, and then you have a new option in here where you can go ahead and create a new user-defined connection and do it this way. Okay, I'm just kind of showing you the new functionality here in 2015, how you do it through the component window or the member edit window. So something else to keep in mind that can make this really even more powerful is you can remember set auto standard connections to be user defined connections. So if I go into my job options into my auto standard connections, let's go to my beam to column tab. I'll go down here to wide flange beam to wide flange column, and for our purposes I'm just going to change flange perpendicular. Let's go to user defined. Let's set to my standard shear plate. Remember, I'm going to want to set my field clearances to be what they need in here, so I'll go ahead and set that to a 1/2 inch. That matches what the non-auto standard field clearances are. And I'll do the same thing for the web perpendicular. Okay, so now let's go in here and I'm going to go ahead and grab all my beams, mark all my beams for processing. Then we'll process and create solid. So what this really should do for me then is redesign all my beams framing to the wide flange column flanges or webs perpendicular with that user defined connection. And if we go ahead and take a look over here, looks like we do have that. And if I take a look, excuse me, let me change my selection filter back to default. Now we got that S3, so again we're getting those standard piece marks used for us. Let's go to a little larger beam here and show you. Same thing. Got that standard piece mark. In this case it's an S4 because I just set it up based on the rows of bolts. So, but it is redesigning using that user-defined connection for us. The other thing about user-defined connections now in 2015 is we can, if we save that through the connection component window or the member edit window, the end preps are going to get saved with that as well. So you may have noticed when I was editing the connection components, I had the end preparations available to me in here as well. So I'm just going to use a simple example that I see a lot. A lot of times users ask, well, I don't want a plain cope here in this shear plate example. I just want the one side of the flange cut flush. That way it leaves the other and potentially get a little more strength out of that connection. So if I go ahead and double click on this connection component, I go under my end preparations to my bottom flange operations. I'll go ahead and lock in the variables that I want to set, and I'm going to do a cut flange flush. Flange length near side I'm going to set to 0, and the flange length far side I'm going to go ahead and set that to 4. So that should just set the far side here to cut flange flush, and we can go ahead and see that there. It did that now. So shows us a couple things here. One, I can change my npreps. SGS2 will design around nprep changes as well. The second thing is this was a user-defined connection, and once I set a user-defined connection, I can still come in and then change the variables on a case-by-case basis if I need to as well. And then again, maybe I want to go ahead and save this as a user-defined connection, so I'll go ahead and hit Save as User-Defined. This one I'm going to call Standard Shear Plate, and I'll call it Flange Flush Far Side. Okay, so now I'll come over here to another beam, and this looks like a good one right here. Edit that beam. Go ahead and set that user-defined connection to my Standard Shear Plate Flange Flush Far Side. And when I look at that, then you're going to go ahead and see it designed that connection, saved those npreps. If I look in the connection component, you can see it had those locked in and loaded those up as well. Okay. A couple other things to point out here. You can actually come in here, and I'm going to edit the member now. Pointed out the connection design lock set flag that you get in here when you lock the individual variables. You're also going to notice in the tree on the left-hand side that the section you locked variables under is going to get a padlock next to it. So in this case, the shear tab on the left end, the shear tab and the end preparations have the padlock by them. Now, I've been coming in here and I've been locking just individual variables. There are lock and unlock all up at the top. So if I wanted to actually go ahead and lock all these variables under this end preparation section, I can go ahead and hit that button up there. Notice it locks every one of those variables in. On the flip side, I could go ahead and unlock all of them by hitting the unlock, and it unlocks all those in that section. I'm going to go ahead and reset that back to the way it was. And last thing I'll cover is forcing connections. How do forcing connections work? Well, very, very similar to previous versions. The one big difference in forcing connections now versus the way it was done in previous versions is since there's no user, it doesn't automatically get all the variables don't automatically get locked in, and if the framing situation changes, the forced connection could update. And I'm just going to use this example here with my beam framing to the column to kind of demonstrate this. And what I'm going to do is I'm going to come in here and edit this connection. I get a failed message, invalid skew to column connection geometry. Well, what I'm going to do is come in here, I'll set this to a bent plate connection. I'm going to go into the connection specifications, and I just want that to be on only the near side. We'll weld it to the supported member. Say OK, process that. And still no connection, so let's go ahead and force that. So I can force that connection, hit OK. I'll process and create solids, and now what you're going to see is probably a little bit of a goofy connection. Okay, so looks like our bent plate is kind of going the wrong direction. Well, that looks to me like it's actually trying to connect to the web, but it can't. So if I would have done this in 7.3 or previous versions, if I made a change to this column, this connection was locked in at user and would not change. So now I'll double click this column and rotate it 90 degrees, and it can go ahead and update with that framing situation now. Okay. How do I prevent that from changing? Because now it looks like it's going to be correct if I rotate my column back. Well, I can come in here and just simply lock this entire end then, and when I make changes to the framing situation, then that shouldn't change either. That connection shouldn't change now either, since it's locked. Okay, and there we go. With forced connections, okay, force is kind of our user in a sense now in relating back to the design calcs, because now if I force a connection and I look in the design calcs, I do have a forced connection note in here now to indicate to me that the connection was forced to get what I wanted there. So forcing connections will give you a note similar to the user connection in previous versions. Okay, so that kind of concludes the information that I have for you here today. We may have future webinars that go a little more in depth on some specific connection types and whatnot to get you a little bit more information. But what we wanted today here was to get you just the basic information and a basic understanding of how the connections work and kind of the capabilities and the potential power of them. So with that, this concludes the webinar.